Good morning, everybody. I'm sure as you heard yesterday, we are going to be doing distance learning for the rest of the year. It was kind of hard to hear. I'm sad I won't be able to see you guys in person, but I hope that you guys will stop by during my office hours and at least say hi. But that means that this distance learning and learning with these videos is going to be really important, and we're going to keep doing this for the rest of the year. So make sure you're keeping on top of it and asking questions if you have them and all that kind of stuff. I hope you guys are all doing okay. And feel free to stop by during my question and answer time to say hi, or if you have any math questions, of course. So today we're going to be we're going to be continuing 4B. So yesterday we talked about what evaluating a logarithm meant, and that meant finding the exponent. And in the definition of a logarithm, we also saw that if we have log base b of a is equal to some number p, it also has to be true that b to the p power equals a. And we're going to be working with that today as well. So based on the definition of logarithmic equations and exponential equations can be interchanged. So as we just saw from the definition, exponential form has a base and an exponent. It's going to be b to the p power equals a. That's our exponential form. And the equivalent logarithmic form is log base b. So the base is still b. Log base b of a is equal to p. Now, sometimes you'll see it with parentheses, especially if there's more than one term here. It doesn't have to have parentheses there. It could just be written like this, log base b of a equals p. So notice when we do a logarithm, it's equal to the power. So it's correct both ways, whether it has parentheses or not. All right, so today we're just changing between the two forms. So on our first examples, all of our equations here, they're all equations because they have equal signs. They are in exponential form. So these are all in the form b to the p power equals a. So what I like to do is I like to identify the base, the power, and then the a. And then we can rewrite it in logarithmic form. Logarithmic form is logarithm base b of a equals p. All right, so let's do our first examples here. The first couple examples here don't have any variables. They're just numbers, and this is a true statement. 3 to the 4th power equals 81. So identify the base. Our base here is 3. The power is 4, so that's the p, and then it's equal to a. So when I rewrite it in logarithmic form, obviously it has to have a logarithm. So logarithm base b, so the base is still 3, filling in the 3 for the base, of a. So a is 81. Here was our a, we labeled it earlier, and then that's equal to the power. It's equal to p, so that's equal to 4. And like I said, you don't have to have parentheses around the 81, but you can see it with parentheses. It helps us to know what we're taking the logarithm of. Now, one thing to notice is when I write this, the log and the 81 are in line. The 3 is a subscript, so that means it's written smaller and lower than the other ones. All right, let's do the next one. So we have 16 to the 1/4 power equals 2. Same thing, let's label the base. The base is 16. The power is 1/4, and it's equal to a, which is 2. So when we switch to logarithmic form, it's going to be log base b. So it's going to be log base 16 of a. So of 2 equals 1/4 equals p. So on one of these, the base is with the power in exponential form. in logarithmic form, the base is with the a, and the power is always on the other side of the equal sign. So just keep that in mind when you are changing between your forms. All right, next one is 3 to the x power equals 20. So the base is 3, the power is x, and the a is 20. So b, p, and a. Now notice these ones have, the next examples all have variables in these. Later on, this is one strategy we can use when we're trying to solve for x and actually figure out what x is. All right, so we have 3 to the x power equals 20. So let's change that to log form. That's going to be log base b, so base 3 of 20 equals p, so equals x. So this is the base, this is a, and this is x. So we're just filling those in b, a, and p. So even if there's a variable, we can just fill it in the correct spot. Notice here I didn't write parentheses around 20. So like I said, you can see it either way. All right, next one, we have 5 to the third power equals x. So this is the base, this is the power, and then this is a. So when I fill this in, I'd have log base b, so I fill in the 5 for the b, of a, so that'd be of x, equals the power, so equals 3. So again, I'm filling in right here, we filled in the base. Here we filled in the a, and then the other side of the equal sign is our p. We're just filling in those numbers in this logarithmic form. All right, two more. 4 to the x plus 5 power equals 16 is our next one. The base is 4. Now this time, this whole expression is p, and then the 16 is the a. So when we write it in log form, it's going to be log base 4, so the b is 4, of a, so of 16, equals, this time the power, the p is x plus 5. So when we fill in the b, the a, and the p, that whole expression was our p-value. And the last one, changing from exponential to logarithmic, we have 2/3 to the 3x power equals 5. The 2/3 is the base. The 3x, again, this whole expression is the p, and the 5 is the a. So when I change it to logarithmic form, I'm going to have log base b, so log base 2/3 of a, so a is 5, equals p, so equals 3x. So again, once we label the b, p, and a, we're just filling them into the logarithmic form. So anytime we have an exponential form, it can always be rewritten as a logarithmic form. Now the same is also true for our next examples. These next examples are in logarithmic form. So the logarithmic form, as we've seen, is log base b of a equals p. Anytime we're given an equation in logarithmic form, we can rewrite an equivalent equation in exponential form. An exponential form is b to the p power equals a. We're going to do the same thing here. We are rewriting these into the other form, except these ones are in logarithmic form. So when we write them, we're going to rewrite them as exponential. So if you look at all of our logarithms, first of all, we know they're in logarithmic form because they actually say log. Another thing to notice, as you can see on the first one, the 64 is not in parentheses, but on the second one, the 3 is. Again, either way is correct. However, if you look at the fourth one down, where this says log base 7 of x plus 2, this one has to have the parentheses because it's not just log base 7 of x, it's log base 7 of the whole expression x plus 2. So that's the only time we really need to have parentheses. All right, so let's change these into the exponential form. So in this example, log base 4 of 64 equals 3. The 4 is the base, the 64 is the a, because we're in logarithmic form, and the 3 is the p. So when I rewrite it, it's going to be b to the p power. So the base is 4, the p or the power is 3, and it's going to equal a, which is 64. So this is the b, the p, and the a. We're just writing them in exponential form in a different order. All right, so next one is log base 27 of 3 equals 1/3. And on this one, the base is 27, the 3 is a, and the other side of the equal sign, the 1/3, is the power. So if I rewrite this into exponential form, again, the base is 27 to the 1/3 power, so b to the p power, 27 to the 1/3 power equals a, so equals 3. So I'm just filling in the b, the a, and the p in exponential form. So those ones just were true statements with variables, or with numbers, no variables, but the rest of them have variables, but we're still going to do the same thing. So the third example, we have log base 2 of x equals 4. This is the base, this is the a, and this is the p. Since it's in logarithmic form, log base b of a equals p. So when I change it to exponential form, it's b to the p power. So that'd be 2 is the b to the 4th power, so 2 to the p power equals x equals a. So 2 to the 4th power equals x. All right, the fourth example, we have log base 7 of x plus 2 equals 2. So this is the base. This whole expression here is the a equals p. So the 2 is the p in this case. So if I rewrite it in exponential form, b to the p power equals a. It's going to have 7 to the 2nd power equals x plus 2. So I'm just filling in the b, the p, and the a. All right, 2 more. Next one is log base 5 of 30 equals x. So on this one, log base 5, so the b is 5, the 30 is a, and the other side of the equal sign is p. So log base b of a equals p. So when we change it into exponential, b to the p power is going to be 5 to the x power equals a, so equals 30. All right, last one, log base 8 of 3x. So this is the base. The 3x, again, this whole expression is the a, and then the other side of the equal sign, the 1.5, is the p. In logarithmic form, log base b of a equals p. In exponential form, we have b to the p power. So 8 is the base to the 1.5 power equals a, so equals 3x. All right, so that's going to be a really important skill, is changing between those two forms. So make sure that we know how to change between those two forms. All right, we're going to stop there for today. So make sure that you do the assignment, and then we will continue with the graphs of logarithmic functions later. Have a good afternoon, everybody.